the third order. So that n, I can give you the form. Maybe I write them one by one. And one is L cubed. It's a third order polynomial. That is why when you are choosing cubic form in ANSYS, the highest order interpolation is the third order, x cubed. Okay? And n2 is L cubed. We have 4, look at this big number, we have 4 degree freedom. So that means we need to form a mass matrix is 4 by 4. Okay? Let's check the dimension first. We have 4 degree freedom, Vi theta I, Vj theta j. So that means we need to form a 4 by 4 M matrix. And if you need to form a 4 by 4 M matrix, that means this one need to be 4 by 1, this one need to 1 by 4. Rho is a scalar. So that means we need a shape function matrix is 4 different shape functions, n1 until n4. So that is why we need to n1, n2, and n3 L and n4 How do we get this form, n1 until n4? I derived a little bit on a linear stiffness matrix method. Why do we have such a form? I derived something like that. It's also derived from energy principle. And I assume the interpolation is na plus bx plus cx square plus dx cubed, and then use boundary condition to determine the coefficients a, b, c, d. So this n1 until n4 actually are derived. You can go back to check. It's not actual form. So when you have n1 until n4, then we can come back to construct M. Rho, so that one, N transpose should be N1, N2, N3, N4. 4 by 1. 4 rows, 1 column. And then times N1, N2, N3, N4. dV. Right? And then you convert the volume integration in terms A dx, because the area, cross-section area along the x direction is the same. Everywhere is the same. So convert dV in terms A dx, and all of the n are functional x. Right? Basically, you can finish the integration. That means from 0 to L, and rho N1, N2, N3, N4, N1, N2, N3, N4. A dx. I convert the volume integration into a length integration along x direction. If the cross-section area of the beam is the same along x direction. Then this is a 4 by 1 matrix. This is a 1 by 4 matrix. So you put them together, you have a 4 by 4 matrix. You have 16 terms to integrate. You have 16 terms. You already have the form N1 until N4. But when you put these two matrices together, you have 16 terms. So do the integration term by term. You can form a 4 by 4 matrix. I just give you the result. This matrix is universal, just as the ME for bar elements. this is a mass matrix for each beam member, beam element. Look at this matrix. It's also symmetry. Because N1 until N4 times another N1 until N4. You just check the notation, you will figure out it should be symmetry. If you do not get a symmetry matrix, that means your calculation is not correct. So this is the M matrix. K matrix is the same as what I have learned in Stimpy's matrix method. So if you want to figure out what is K matrix, you can check your notes. There's a name for this. This is called consistent mass matrix. Consistent mass matrix is calculated from that integration. Basically, in finite element or in ANSYS, you click one option, so-called lumped mass matrix. When you do the vibration analysis, in the third problem, or in the last Friday I did a tutorial about how to do vibration analysis, I click a lumped mass approximation. So what does that mean? That means we are not using this mass matrix. In ANSYS, we use approximation. This is the beam member. Density is A, cross-section is A, density is rho, cross-section is A, length is L. So what is the total mass for this beam member? This is the volume, right? Cross-section area times the length. This is the volume of this beam. And then times the density. This is the total mass. And then we are using 2-degree freedom to represent this much mass. So we just assume this mass will be evenly distributed on these two nodes. And then this will be rho L divided by 2. This will be rho L divided by 2. This is called a lumped mass approximation. We lumped the total mass into the two nodes, into the two joints, and has nothing to do with rotation. So, and then, what is a mass matrix? So this one will be rho Al 2, 0, 0, 0, 0, 0, 0, 0. Why it is 0? Because this is Vi, this is theta I. We just lump the mass into the deflection. And this one is 0, 0. This one becomes rho Al. So this is the mass matrix in the lumped mass approximation. We will assume the mass of the beam are evenly distributed into the two nodes. And one of the nodes just share 1/2 of the total mass. Has nothing to do with rotation. So this becomes, we do not calculate this. This is just an assumption. People just check. Based on this assumption, you will get a very good accuracy. It's not that bad. So it's not exactly accurate, but it's acceptable. So, but we'll simplify your calculation. If you simplify this, this is Vj theta j. Basically, we choose this option in ANSYS calculation. So if you simplify this, rho L to 1 0 0 0 0 0 0 0 0 0 0 1 0 0 0 0 0. The name for this is called non-mass. Actually, we can make the same assumption for bar element. In bar elements, we can make the same assumption, just evenly distribute that mass onto the two joints. So this is, I'm going to go through a procedure, one example very quickly. Suppose you have a beam member, it's fixed on both ends, and you discretize this beam member into two elements. This is the first element, this is the second element. And then I'm asking you to calculate what is the eigenfrequency of this beam member. Because right now you have 1 degree freedom right here. So this degree freedom must be vibrating this way. If you discretize this beam member into two elements, this node or this joint can be moving, right? Deflection, rotation. So you have a degree of freedom at here. Although these ones are fixed. Okay. So what is the vibration frequency and what is the vibration mode for this structure? We start with lambda mass matrix. That will be much easier. So M1 will be rho A L. Suppose each of them is L A rho. Each segment have the same length, area, and density. 1, 0, 0, 0. And will be equal to M2 because these two elements have the same density, have the same area, and same length. So this is a mass matrix. And then what is K matrix? K matrix is the same as what I have learned in stiffness matrix method. So I'm going to copy that for you in case you forgot it, because nobody will remember this. Equal to K2. This is V1 theta 1, V2 theta 2. This is V2 theta 2, V3 theta 3. We do not apply any boundary condition. This should be the column index and row index for the mass matrix and stiffness matrix. And then we apply the boundary condition. Before we do the assembly, we can apply the boundary condition. Because this structure is very special, both the joint and the third joint actually are fixed. You only need to worry about V2 theta 2. That means for M matrix, you only need to worry about, this one, V2 theta 2 here. V2 theta 2. And for this one, V2 theta 2. Right? Because V1 theta 1 are fixed, V3 theta 3 are fixed. So if you apply the boundary condition and then do the assembly, the total M will be 2, 0, 0, 0. Because M1, M2 are the same. This block, the overlapping, will give you this matrix. The coefficient is rho A L over 2. This is a global mass matrix after you apply the boundary condition. I skipped one procedure, apply the boundary condition. Cross out some rows and columns and then do the assembly. M1, M2 is the same, P1, P2 is the same. So Q prime will be EI V2 theta 2. Will be 24, 0, 0. Why is 0? This is column index for the second V2 theta 2. It's a column index for K2. If you check the column index for K1, this one is V1 theta 1, V2 theta 2. So for that one, you need to use this block to do the assembly. So anyway, that is the assembly procedure. I skipped the assembly procedure. I assume you know how to do the assembly. Okay? After you finish the assembly, this is the K matrix you can have. And then all of the other things are the same. K prime minus omega square M prime equal to 0. Right? 2 by 2 matrix, 2 frequencies to figure out. 2 by 2 matrix, this one is 2 by 2, this one 2 by 2, this is unknown. Determinant is 0, you can solve for omega. And then eigenfrequency, eigenvector. So I'm going to stop here. If you have questions about homework or project, I can hear that.
You say I can hear nothing? If you have any questions on the project or the homework, I can hear nothing.
I don't think that's what he said.
I think that's what he said. I don't think that's what he meant. Go up there. How do you do it? You started at it? What? You started at it? I tried. I couldn't figure out how to start it.